who's going to talk to you about Agile and Mobile. If you read the bio of Phil, very brief bio in there, I like the fact that he wants to work out how to transform passive actions on a keyboard into things that people like. So hopefully you might tell us a bit more about that. But over to Phil, and we'll finish the session at 5 o'clock, ready to line it up.
Right. Can everyone hear me okay? The last talk I did about a month ago, I had an ear problem at the time and I was completely deaf. It was really weird trying to project my voice without being able to hear it myself. But it's a bit better now, but not 100%. It might be a bit of a problem. We do a bit more user discussion later, so we'll see how that goes. I printed out some handouts because putting links on slides is never that practical. I did it at the last responsible moment, just as I was leaving the house. I meant to print out 50. The printer stopped at some point. I think I've got about 12, so you might need to share them. So I'll just sort of dish them out. This one per row for now. We'll see how we go. Okay, so let's get started then. So I'm Phil Nash. My background, well actually at the moment I'm mostly a Windows developer, but I've actually been working on and off in mobile for about 13 years. And had an app out from almost day one of the App Store, and I've had a few apps since then. So I have a bit of experience in that side of the industry. I've also done some coaching for a large corporation in a TDD and an iOS environment, so I've seen that from that side as well. So we're going to look at the intersection between Agile and Mobile. And start off with wordplay. As the title suggests, the words sound very similar, really. If you look at them just linguistically. If you look at the raw definitions of the words, I just pulled this straight off Google. Just did a Google search to define Agile. It's the first definition it came up with. Able to move quickly and easily. I think we can see how we try to capture that in Agile practices. But that's the original definition. I like the Agile as a monkey bit as well. I'll leave it to you to see how that fits in. And I hope you brought your Agile mind with you. So what about mobile? Again, same Google search, define mobile. Able to move or be moved freely and easily. Sounds very similar, put them side by side. Able to move quickly and easily, able to move or be moved freely or easily. They sound like they're so close. And yet, when we put back our sort of technical interpretations of these words again, we see, well, Agile, we're talking about our approach to software development. Mobile is the environment that we're developing for. I'm not comparing quite the same things, but there's no real reason these days of vertical integration that we shouldn't have the same principles running the way through. So is there a relationship between these two things? Well, I think it's complicated. Before we get on to why it's complicated, we need to define exactly what we mean by mobile, or at least what I mean in the context of this session. What I really mean is starting with the original iPhone back in 2006, 2007. So I've been developing for mobile for about 13 years. That predates this, but it only really applies from about this time. And of course, all the iPhones that followed it, particularly accelerated by the iPads, and maybe one or two Android devices as well. I suppose we should give a token mention to Windows Mobile, maybe even BlackBerry. I think they're the only players left now. But actually, it's not just tablets and phones we're talking about. We've got a whole future generation of devices. We'll talk about getting into wearable devices now. Watches, bracelets, who knows what else they're going to go out with. But these are all based on the same principles. small, low-powered devices carry with us all the time, we have quite high expectations of. They're quite powerful. So really we're talking about what's been called the post-PC era of devices. And maybe we've been able to ignore it from an agile perspective until now, because it's not really encroached too much on the enterprise where a lot of agile efforts have been focused. But it's a hugely growing segment of the industry, as you can see. So I said the relationship there was complicated. Why is that? To paraphrase James Brennan, who talks a lot about TDD in an embedded context. He likes to, in a talk he gives, a client who says, we're special because of these embedded requirements we have. Mobile really is sort of an evolution of the embedded world. When I first started 13 years ago in mobile, it really was much closer to just embedded computing. The constraints were so great, you just couldn't apply the sort of same principles we have in desktop and server world. Moved on a lot since then, particularly since the iPhone. Can we still really say that it's special in the same sort of way? Well, I'm going to argue that it is special. And it's special in a way that deserves some special consideration. And I'm going to look at three areas where I think it's still special. One is I'm going to argue that it's a constrained environment. We'll look at why in a moment. Also going to look at the angle of appliance computing and what that means. And I'm going to look at some of the challenges of device testing. So that first one, constrained environment. As I said, these devices have got much more powerful in recent years. Just how powerful are they? Well, I pulled this chart from the Wikipedia page on Moore's law, and we can see quite clearly there the curve, this is a logarithmic scale, of transistor counts through the years from 1971, really closely tracking that Moore's law line. It's quite impressive. Even up until, this was 2011, but fairly recent. There's I guess a little bit more messy up here as we go to multi-core and low-powered chips, but it's still pretty impressively tracking that line. It's a bit of an outlier there with the Intel Atom, which you could argue is sort of closer to a mobile chip, but most of these chips are sort of desktop and server grade. Where do mobile chips fit in? It's actually really difficult to get transistor count numbers for ARM processors. I think it's because a lot of that's left to individual manufacturers rather than being baked into the ARM specs. But I sort of dug around, I've got a few hints and guesses. I'm not going to say these are actual figures, but I sort of worked out that over the same period it's going to be somewhere around here. Transistor count hasn't gone up a lot in that time. Loosely corresponds to, well, over a decade, maybe 15 years ago, if you go by transistor counts. But it doesn't really matter, that's a bit of a fudge, because transistor counts haven't really been a good metric for performance for a long time. Comparing them between ARM architectures and Intel is a fool's errand, because the whole point of RISC architecture is to reduce the number of instructions, which reduces the number of transistors required. So that's not a very good way to compare. So suppose we're going to look at benchmarks. It's actually quite difficult, again, to get benchmarks to compare the architectures. But Geekbench has some, for all its faults. It's worth looking at. And I found this interesting comparison between this MacBook here, the latest and greatest from Apple, Retina MacBook Pro, comparing that with the latest and greatest iPhone 5, at least until next week. According to the Geekbench score, there's an order of magnitude difference in the benchmarked performance, whatever that means. Sounds a lot, but it's not that bad either. And considering how powerful these, and this is a quad-core machine now, how powerful they are. Just try and get more of a feel, how does that sort of fit into the historical context? Well, I went back through the Geekbench history to see what processor corresponds to that sort of figure. And I found Intel P4, 550 and 551 models, running at 3400 megahertz. This is smidging below the same figure. And actually not much more than that, you get to the Intel Core 2 Duo. Quite recent, 2006. That was a new chip. So the iPhone 5 is approximately just slightly less powerful than Intel Core 2 Duo laptops. That's pretty impressive when you think about it. So how can I argue that this is a constrained environment? Well, although we do have a lot of power, there's a number of reasons why you might not want to use it. Main one being power management. We need to have these devices with us all the time. They need to run on small batteries and go, hopefully, at least a whole day on a single charge. Ideally more than that. Still pushing the boundaries there. Apps that constantly use the full power of the device are going to drain the battery really quickly. If you've ever used a sat-nav app in a car without a charger attached, you know how quickly that runs down. So well-behaved apps need to be conservative with the power that they use. So it's an artificial constraint now, but a constraint nonetheless. But probably a bigger constraint is actually to do with memory. And I'm going to labour this a bit because I think it's actually not a particularly well understood angle, which does have an impact. So again, the iPhone 5, using that as a benchmark, that has a gig of RAM, which sounds fairly decent. The original iPhone only had 256 meg. And even a couple of iterations later, we took about half a meg. Still a lot of these sort of devices in use today, running at half a meg, gig, sorry. I know a couple of the higher-end Android devices now. I think the Galaxy S4 has 2 gig. We'll come back to that in a moment. Possibly the to be announced iPhone will have as well. There are some reasons though why that 2 gig might be the theoretical limit for a while. So we're used to memory following a similar path to Moore's law, increasing sort of exponentially over the years. That certainly happened with desktops and servers. But there, the memory is actually typically separate from CPUs. Mobile devices, everything's system on chip or package on package. This is a top-down view of the A6 chip in the iPhone 5. And what we have here, this whole sort of yellowy browny area covering most of the surface area on the top is the RAM. It's covering most of that surface area, which means all else being equal, if you want to double the RAM, you're going to have to double the size of the chip. And that's not the direction that they're going in, particularly when you look at die shrinks. I don't want to get too technical here, mostly because I'm not that familiar with chips at this level, but according to this chart, apart from the big jump from the A4 to the A5, which I think was mostly due to GPU, the trend is for chip size to get smaller, particularly as the process size, which is the 45 nanometers there, down to 32 in the current generations. As they get smaller, the whole chip gets smaller. I think the Galaxy S4 again, I think working on a 28 nanometer process. But it's a bigger chip, and I think that's because it actually has 2 quad-core CPUs on it. So maybe that's how they get the 2 gig on board, and why that may be the theoretical limit, because they're not going to go bigger than that. We'll see what Apple comes up with next week. That's going to be interesting. So we're looking at probably 1 to 2 gig limit of RAM, no swap file. Then we also need to take into account the operating system and other background processes. It actually turns out that even with 1 gig, you're probably going to get your app killed if you use more than a couple of hundred meg. It should stay in sort of under 100 meg if you can. That's starting to sound quite constrained. It gets worse when you start taking into account garbage collection. The garbage collection obviously frees us up from having to worry most of the time about memory management and a whole class of errors and avenues of debugging there. So generally, we've got used to having garbage collection in modern languages, and we're sort of used to this sort of performance from the garbage collector, that it matches or exceeds native memory management performance. The reason it can exceed it is because it can be much more efficient at allocating memory. So, we're happy with that. The trouble is, to get that, we typically require 5 times the amount of memory that our application requires for the garbage collector. 5 times is a lot when you're dealing with constrained memory environment. You drop down to 3 times, actually it's going to run 17% slower on average. These are figures from quite an old paper that I've got links for in the handout, but they haven't changed much. And that's still 3 times the amount of memory. Drop down to 2 times, start to jump up exponentially, 70% slower. Now that's the speed of the garbage collector itself, not your whole application. So you might even think, an average app, you can live with that, running 2 times the amount of memory. Trouble is, these devices that we've got used to, the responsiveness of, we have a much more visceral connection with them. We touch them, we talk to them, we hold them in our hands. When we're navigating through a long list or moving things around on the screen, a slight glitch in the performance, even if just for half a second, that breaks the illusion of that connection we have with the devices. So we really want to avoid those sort of glitches that will come from a garbage collection course. One of the main reasons that Android's taken so long to catch up with the iPhone in terms of scrolling performance, amongst other things. So this is still quite a big issue. And although Android devices with derived, which is a version of Java, have garbage collection, you actually look at what people are talking about in forums, particularly games development forums, anything where performance or memory matters. A lot of discussion is about optimizing the performance of the garbage collector. The very thing that's meant to save them from worrying about memory management issues is causing them to spend a lot of time thinking about memory management issues. So, whichever way you look at it, Android, you've got garbage collection, but with caveats. In iOS, we've actually got manual memory management. Apple have chosen not to give us a garbage collector. So, a lot of time on a project is spent dealing with these sort of issues. Developing for it, debugging it, profiling it, dealing with crash reports. That's a lot of time on a project dealing with stuff we have got used to the idea of not having to worry about anymore in a typical agile project. That's why I think this is relevant, because this is not something you tend to catch when doing TDD, for example. It's something you need to allow extra time for in an iteration, in your testing time frame. Something there. So that's why I'm arguing that mobile is a constrained environment, and why I think it matters when it comes to what agile practices we can adopt, and how we do it from an agile perspective. We will come back more to this a bit later. I want to move on to my second area, appliance computing. Now appliances, familiar with washing machines, kettles, toasters. The idea is they've got a simple interface. You press a button or two and they just work, they do a job. They break down, we throw them away, or we get them fixed, but we don't generally think with them. They're very much black box, very simple, and we have high expectations of them being reliable and working. Appliance computing is taking that same principle to applications and keeping them simple, focused, doing one thing well typically, being reliable and being responsive. It seems to be on much better grounding it. These are the sort of things that Agile tends to play into well. Minimizing waste, not coding things that we don't actually need ahead of time, eliminating requirements that are not needed by having the conversations early. All those sort of things will tend to lead us to those small focused apps more readily. So that's the good side. Downside is users still expect a high level of polish on these things. So although the interface itself may be simple, what's going on behind the scenes may actually be more complex. On one hand, you may have to spend a lot of time on sort of design and artwork and those sort of things that maybe you want to push off. On the other hand, you may have to drop to sort of low-level APIs like OpenGIS to get sort of responsiveness and graphics performance necessary to give the illusion of simplicity. So it's not necessarily all going to play into an agile mindset. We may have to think about things a bit differently. Then there's the it just works angle. Unfortunately, I don't think Apple have been as good at this in the last 5 years as they used to be. Hopefully they'll get better again, but still the principle is there and it's infected the whole of the post-PC ecosystem. Now these things should be very reliable. Again, that's what we do agile for, isn't it? And that's great. The expectations are really high. If we say we're doing agile on this project so that we can get that reliability that people expect, and we still miss it, it doesn't look so good. So I think that's relevant as well. That's device computing. Device testing is interesting. If we've been developing on desktop machines, we're used to being able to immediately run our applications, test them there and then, get results, automate results easily. It's not more difficult when you've got to actually push out to another device. It's a lot simpler than it used to be. It used to be like an hour turnaround, flash, expensive development chips. So now you can do it in moments, but still. And that's quite a lot of extra complexity when you're trying to have a quick feedback cycle, and particularly automating the tests. Remember, the interaction metaphor with these devices is very different. As well as touch, you have multi-touch. They're quite difficult to simulate. You have accelerometers and rotations. Maybe we have location services. These are things we're not used to having to simulate. So how do we automate our device testing? I'll show you something really cool. This video is actually an early prototype. It's apparently a lot more sophisticated now, but we haven't made a new video of it. This is a cloud testing solution. You write scripts in basically a cucumber like manner, and that will actually instrument UI automation on a device. And of course, it handles all the rotations. You can send it off to the cloud, and it will also handle the fragmentation, particularly on Android, by testing on loads of devices simultaneously. So this could be done. This is a real thing. The company that does this, less painful, they're famous for Calabash. You may have heard of it, which is a Cucumber UI automation solution. They were acquired this year by Xamarin. So this is now Xamarin in the cloud. So I expect this to get a lot bigger in the coming year. It's expensive though. For a big corporation, it's probably an ideal solution. If you're like a one-man, two-man shop, you're not going to be able to do this. You're going to be stuck with that manual testing. So there are still plenty of challenges here. This doesn't cover everything. So that's device testing. There is one more thing. I thought I was going to do a Steve Jobs quote. Well, he wasn't the first guy to say that. There's a thing called the maximum viable product. So we used to talk about the minimum viable product, and that still applies here, but a different spin on it. So the maximum viable product is actually typically associated with prosumer software, and it's a lot more common than that. And it's basically the idea that it's a product that's as good as the market will bear. It's the opposite of the minimum viable product. The reason I'm mentioning it here is because although this isn't typically what we encounter in the mobile world, it's definitely had an influence on it. As I said before, production values are very high, particularly if you want to have your app taken seriously. If you think in terms of a minimum viable product, you're much more likely to want to push something out that's got a very low level of polish. It may have the features there, it may be bug-free, but it may not get the traction you need to get the feedback you need, because people are just ignoring it because it doesn't look good enough. It doesn't have those extra things that they've got used to. So I don't think this is relevant. I think it is something that just going to require us to rethink some of our approaches. So that's some of the technical challenges with the platform. Now what about the development process? Is that special? When I started iPhone development 5-6 years ago now, this was pretty much the de facto approach, including myself. We're just hacking, see what we could do, see what we can't do, see what the market was like. And we're really new, it's the gold rush days. A bit of that pervades to today. I mean, there's always going to be cowboys in any industry, particularly so close to that gold rush period. But it has matured. There are some very polished apps and production studios out there. The really rubbishy apps are falling by the wayside. Things are getting better. But it's all happened in such a short space of time that some of the principles that we like to associate with Agile haven't necessarily come through yet. But I do monitor the industry, and I try to follow those people that are taking these things seriously. There's a list of people to follow at the bottom of that page. Hope to add to that list. It's not very long. One of the guys there, John Reed, is the author of OC Handcrest, which is, as you might imagine, Objective-C port of the Handcrest matches library. He's also a bit of an evangelist for TDD and iOS. This quote a little while ago, it's obviously part of the conversation, you haven't seen the whole thing here, but he's talking about getting 100% test coverage in his iOS apps. I don't think you necessarily need to achieve that, particularly in view of some of the challenges we talked about. But John showed you can do it. It is possible, and he's getting good results from it. You can tell from the other half of the conversation, you haven't seen the other guy, Marco Zara, hasn't had such a good experience. He's also quite a big name in the iOS community, particularly as a specialist in core data. I've actually spoken to him at a conference, and apparently he used to do unit testing religiously. He pretty much has given it up in the context of core data because there's just too many issues to overcome. I don't think those problems are insurmountable. I think they're worth overcoming. Recent blog post, I think my blog site is on that page as well. Up and up covers some of those challenges as well. I won't go into them now. But this sort of gives you an idea of the mindset we're up against. This is even more telling. I'll read this one out because it really needs to get inside. Same guy. I asked Apple engineer his testing questions at WWDC. That's the Apple Developer Conference. They were genuinely surprised that I had unit tests on an iOS app. These are Apple engineers. Bear in mind, Apple actually ships the unit test framework with their IDE. I think that goes to show how rare the unit testing is, let alone TDD. There's another one. Sorry about the walls of text, there'll be a few more of these. Josh Abernathy is one of the lead iOS developers at GitHub. Again, he's fairly well known in the industry. He says, I have this theory that because iOS apps are typically relatively small, we don't feel the pain of bad practices. So the implication there is that the bad practices are very common. The other implication, which is interesting, is we seem to be getting away with it. And I've seen this sentiment expressed a few times. There was a blog post a while ago that made the rounds about someone who came from a very agile background, crossed over to iOS development, realised that they didn't actually need those practices. They were just getting high quality stuff done, just by doing high quality stuff. Obviously, we don't need to prescribe specific practices. We need to adapt to the situation we're in. But there is this feeling that Agile is just not necessary in the iOS development model. And there's something to that. I don't think it's the whole story. I'll come back to that. This one is interesting. I did a blog post in response to this. So again, the blog site's there. Marco Arman was the first developer on Tumblr. Then he founded Instapaper. And then more recently, he launched the magazine, which is a newsstand magazine app for iOS. 3 really successful projects. 2 of those completely on his own. So he's very well respected. Obviously successful, so people look to him as a model of how to do things. Till last year, he was doing a podcast called Build and Analyze. And he made this comment in one of the last episodes. It's about his brand new code base for the magazine. Again, I'll read this out. When code gets to a point where it's like a giant pile of messy spaghetti, it feels very fragile and you feel like, oh my God, I need to add an attribute to this. Is that going to break anything? Sound familiar? Heard that before? What's amazing is that in the same episode, he was responding to a listener question about logging and testing, test-first development. And here's a bridged response. Test-first development is a whole lot of formalism, which matters a lot in an enterprise environment, but I don't really do any of that stuff. So, dismissive of it, but that's fine. That's what he does. It gets worse. All of this structure and all of this overhead, and he's particularly talking about continuous integration here, we wouldn't be able to release this software as one person, have it stay competitive, and have it released frequently. There wouldn't be enough time for that. Now, I know this is a common misconception. We hear this a lot. But people don't believe that doing things a certain way with some extra overhead can make it faster. But I picked this because I think he really epitomizes the prevailing attitude in iOS development. And also because he is quite well respected, and he said this in a widely listened to podcast, and a lot of people will be listening to it and thinking, yeah, that affirms my position. So this is becoming an entrenched view. So, given his earlier statement about his messy spaghetti code, I think there is a clear case for trying to tackle this sort of mindset. What's less clear is exactly which practices do apply and when, and how we overcome some of the challenges involved. Whether we need to come up with new practices, or whether it is actually worth the effort. So, this is the point where I want to try and open this up to discussion a bit, if I can do. Just try to summarise the 4 key points that I covered, but don't want us to be limited to this. This was just my sort of view of the matter. So any questions about any of the things that I've covered, or answers, even better, or open-ended questions that don't necessarily have to be answered here, just really want to capture them. They don't want to have any opinions.
I'm an embedded systems developer.
So I'm already having trouble hearing.
Sorry. I'm an embedded software developer. And at least 3 out of these 4 issues even we face a lot, though we actually use a lot of Agile at our place. The only one I think that doesn't apply to us as much is when you spoke of competitiveness, because we are not really competing on the iOS or Google Play Marketplace as much. We are not trying to release an app which somebody else might release before us and take over the market. We are not trying to create something that will beat Angry Birds. So we create bespoke solutions. But I related a lot to at least the first 3. We have constrained environments. We often have to work to write software for appliances, literally household or lab appliances. And automating device testing has been the toughest bit because we rarely manage it. possible to do it is if you can have generic outputs and you can simulate it. But sometimes, at least you get the feeling that the cost of that might not be worth instead assigning one person to simulate what the device does. So often, I mean, not often, okay, I've not been there for that long, but I get the feeling that sometimes on-device testing is best just done by a human being instead of a automated setup.
Right.
Seems like it.
I'll just try and summarise what you said, at least to confirm that I've heard you correctly. So you've been doing iOS development?
Not iOS, embedded.
Embedded development,
Yeah.
but using some agile principles?
Yes.
You found that the constrained environment aspect really applies?
Yes.
And that it's, although you can do some things like automated testing, it's not always worth the effort?
At the device level, we do unit tests, we have a build server that runs tests for us, but the on-device testing, we generally need a human being.
Right, yeah. Yes, I think that's quite common. Certainly when I was doing mobile development in the earlier years, that was definitely the only way you could do it. But the fact that it's become possible now, I think, maybe we've crossed to the point where we should be doing more. But I think that's the big question is some of these things are possible, but are they worth it? Just because you can get 100% test coverage, for example, doesn't always mean it's worth the effort. And where to draw that line can be, I think, particularly tricky to track, especially when everything's changing all the time. The technology is moving on. And some people are solving these problems, like the cloud testing solution. So it's, obviously there are different experiences, and they will be, continue to be. We'll see that everywhere.
Yeah.
Of course. But, yeah, thanks for your input.
What do you mean by embedded development?
Sorry.
So-
I'll come a bit closer.
Is there a distinction? You said embedded. What do you mean by embedded? We make a distinction here between mobile browser and mobile app.
So, well, what do you mean by embedded?
Software that generally lives on electronic devices to do work with specific inputs and outputs, and not on that doesn't live on computing devices as computers or mobile phones. So we're talking about how heating controllers and
Okay.
lab equipment and stuff.
Yeah, I think as I said earlier, the early mobile development was much closer to embedded, whereas now it looks a lot closer to desktop development, but it's not quite there yet either. Yeah.
So by that same logic, if we started off at the embedded end of the spectrum and desktop computing was the other end, mobiles are going that way anyway, and desktop computing is coming back the other way, so that you've got touch capable and orientated desktops now as well. They're
Yeah.
quite popular. Are we going to see some of the reasons why people don't bother doing as much testing on mobile devices appearing on desktop devices, or are we just going to see? Do you see what I mean? It's like which middle ground are we going to fall onto? We're going to become a more mobile like ecosystem, or we're going to become eventually everyone's going to be back to the desktop environment because mobile devices will effectively be as good or as testable as desktop.
To lose you a bit again there, but are you saying that mobile devices are becoming more like desktop or the other way around?
Well, I don't know is what I'm saying. I'm saying desktop devices are becoming more like mobile, and mobile devices are becoming more like desktop.
That's true.
So
We seem to have another point of convergence.
yeah, so there, but I'm not sure at what, it's not going to be 50-50. It's not going to be like, oh, we'll become good like you become good like us. They'll probably go more.
A good example of that is the next generation of the Mac operating system.
Oh, yeah.
Has a lot more features for low power management on laptops, extending the battery life, and API hooks for your own apps to be more power efficient. So there's a lot more interest, even in the desktop world, in certainly the low power requirements. But I wouldn't be careful to look too much at past trends and the Moore's law prediction. They don't always hold. And I think we are seeing a point where some very rapid progress, certainly in processor performance and memory, are going to start leveling off. Particularly the RAM, which is why I sort of went to some lengths to try and explain why, at least to my knowledge. So we're not necessarily going to see mobile performance catching up with, at least where desktop performance is now. But maybe more so the other way. That's a good point. Next one first.
I actually work at the same company as
Okay.
Addy over there.
We have a completely different view.
I'm the tester.
Okay.
I think it boils down to the testability. When it comes to the mobile platforms, they're gradually becoming more testable.
Yes.
Desktops already have that testability, and so you can still do that kind of thing. The issue with embedded apps is there's not the testability, there's not any testing framework. We've got around that somewhat with cross-compatibility, so compiling it on desktops, and that's how we can run unit tests. But then, obviously, there's still the end-to-end testing, your acceptance testing, which still needs to be performed manually, and that tends to be the crux of the issue when it comes to testing that kind of thing.
Yeah, that's been very similar to my experience in iOS development as well. The approach I've converged on is to do as much unit testing as possible by taking the code out and running it in a standalone desktop app, which fortunately is a lot easier to do with Mac and iOS because there's a lot of compatibility. So I can run the core of it as a Mac app, and that actually encourages me to make more of that code testable, or more of it out of controllers and view and model objects. But then for the end-to-end tests, use more of the UI automation solution like the Calabash framework. So yes, I think that holds equally to mobile. It is getting better. There are frameworks appearing like Calabash, but it is still much harder to test, and so that point at which it's worth it is still pushed back. So I think it's reinforced that.
Are you on about individual app development or something different?
Sorry,
Are you on about individual app development?
individual app development.
Well, I don't want to get ridiculed, but I work on a Windows development, and I don't see any different in developing for Windows Phone than Windows Desktop. You can use the same process there. There's no difference.
Similar situation to developing for iOS on a Mac. You use the same languages, a lot of the same APIs. Sorry, too close to the camera.
Same test framework.
So yeah, it does seem very similar. Actually, the APIs are a bit more different than on the Windows side. But it's when you start to get the constraints of the environment and all the additional sort of areas of testing you need to get into, a lot more manual work, much harder to automate certain things. I mean, even with Windows Mobile, you have rotations and multi-touch and those sort of things that you don't have to deal with on the desktop. So I don't think it's really any different. But I don't have experience of developing for Windows Mobile. So, Joe, you saying you have different experience of it? Then?
I don't see a lot of difference. I can't imagine why people can't do unit testing.
Well, you heard it here first. We need to all migrate to Windows Mobile. So it's much easier to develop for. But maybe that's it. Maybe Apple and maybe Google need to do more to
Use the same tools.
level the.
I'm looking forward to
Thank you.
that with the thing, right, when they get that going. I think, guys, it's 5 o'clock. It's a scheduled time to finish. I think it was a thank Phil for his presentation.